So as we discussed, in order to do hyperparameter tuning, there's different strategies and different techniques that you can do hyperparameter tuning. But first, you need to find your hyperparameter. There are several methods like the grid search or random search to find the hyperparameters within your model. After you find it, then you aim to optimize the model hyperparameters. To discuss here, we have, three methods that we are gonna implement here. So first, we'll take like our random forest classifier and adjust its hyperparameters. Also, the KNN model, as well as the logistic regression that we have. So to start with, we'll start by doing hyperparameter tuning by hand for the KNN model, which, if you recall, that it had the lowest accuracy percentage with around 68% only. So to start with that, let's only just take a look about how we can optimize the KNN model and how we can change the hyperparameters. But as we discussed, like many models, including the KNN and the random forest and the logistic regression that we have to optimize, they have several hyperparameters that influence their performance. The baseline model may not have the best parameters, hyperparameters, as we discussed. So it's important to optimize them first by using some techniques like the grid search, as I mentioned, GridSearchCV or random search to find the best hyperparameters. So let's start with the KNN model, and let's try to tune the hyperparameters of the KNN model. To start with that, let's add some comments here. So we'll say that let's tune KNN model hyper parameters. So the first thing we have to identify here is the train scores that we already had before. Scores, which is equal to an empty array. Next, we also need to define the test scores. Also, it need to equal to an empty array. Now let's create a list of the different values for n neighbors. To do that, we're just gonna define neighbors equal to a range. That range has to be from 1 to 21. Next, let's set up the KNN instance. To do that, we're just gonna start typing. Let me comment this out. So what we were saying, okay, we need to set up a KNN instance. So let's start by defining KNN is equal to KN. Okay, KNeighborsClassifier or regression. Okay, so we'll go with the classifier in our case. Next, let's loop through different neighbors. Okay. To do that, we'll go with for loop. I n neighbors. Don't worry, because we're gonna explain each of these codes and what does it mean. Let's set KNN dot set the parameters that we let's set that into n equal to I. Next, let's fit the algorithm we're gonna use. That has to happen through KNN dot fit. We'll take the training dataset, including the X train, and also the Y train data, where is the labels of the training data. After that, let's update the, let me write, comment that down. So update the training scores list. To do that, we'll do train underscores dot append we'll use the KNN score again dot score, and then we'll go with the X train and Y train data. Y train so now we're done from updating the training. Okay, so we have what next? Let's now update the test score list. To do that, we're gonna use the sim function or the test score dot append function, and we'll use the test dataset that we have. Test score dot scores dot append. We'll again use the KNN dot score. This time we'll go with the X test and Y test dataset. So this code is a great approach to tune the KK or KNN neighbors model, which is the K nearest neighbors, by evaluating its performance on different values that we have here on the neighbors. So let's run this code. Okay, we have no error, that's good. So also, how can we, interpret the plot or the results that we are gonna produce? So let's say the training accuracy. Typically, it's a number of the neighbor increases. The training accuracy should remain high or even increase. With the very small values of the neighbors, example like n neighbors equal to 1, for example, so that is going to go from 1 and then 2 until 3 and then until 21. So that we're going to loop through all of these. We set that into I in our case. So it's going to take each value of from 1 to 21, going to try it, and then the model may, overfit, leading to higher accuracy on the training set. Also, when we use the test accuracy, as the n neighbors increases, the model might become more generalized and being able to detect the patterns. Initially, like test accuracy might increase as the overfitting is reduced. However, after a certain point, the test accuracy might also start to decrease, indicating that the model is becoming too simple when we call it like the overfitting. To evaluate that, let's call these train scores that we have created here and see how is the initial results that we have. Mhm. As you could see that it has started from 1, and if you count them, you will find that it has stopped here with the, trying different uh, in neighbors values. So start with this one. So I think it's the best one here we have is to set it to 1 since it holds the highest training value. But let's see now the test scores. So as you could see that we could see that some of the higher values here we have, maybe it's on the array number 1, 2, 3, 4, 5, 6, 7, start from 0. So I think it's the 6th place. Also, we have also in this place. So you can consider like here to see which settings of your KNN model should, go with. To go back to the train score, so the train scores, as you could see that you have, it will help you to understand how well your KNN model is performing on the training data for different values of the n neighbors, as we mentioned. This information combined with the test scores allows you to identify the best value for the n neighbor. In our example, we set it into 1, but in our case, we might set it to 0 or 1, for example, as it has the highest results. So as we mentioned, this will allow you to identify the best value for the neighbors that you have to set here that achieves the balance between the bias and variance, leading to better generalization on the unseen data. So to summarize again, how is this working is that As you've seen that we have created for loops, it starts from 1 and ends by 21. So the loop interacts over values of n neighbors from 1 to 21. And during each iteration, the model is trained on the training data, which we have on the X train we have set here. And the accuracy on the training set is computed using KNN.score, as we have highlighted here. So the training accuracy, as we have seen here, we have when we call the train scores. For each value of the n neighbors, the train scores list holds the model accuracy for the training data. This measures how well the model is fitting the data it was trained on. While this code also returns the accuracy score, which is the proportion of correctly, the accuracy here means which are the proportion of the correctly predicted instances out of the total instances in the training set. So think as this setting itself, which is equal to, in our case, is starting by 1. Here you have, it could predict 80% with accuracy percentage. So as we mentioned, like the train scores, when we call it, this will help us, to understand how well the KNN is performing on the training data for different values, the neighbors. And that information, when you combine it with the test scores, it allows you to identify the best value for the n neighbors that achieve the balances between the bias and variance. So think in our case that we have here the highest value in 1, and we have, let's say here, for example, if this was on 15 place, so you can just set the n neighbors range. It goes, you can set the train score here is equal to 1, and then here you make it equal to 15, and you don't have to go through the loop. So the loop, we used it just to present to us all of the accuracy results that goes from 1 to 21. So this is the way of how you can, optimize and find the best hyperparameters of the KNN model, for example. You listed the train scores and the test scores. So this is for the train scores. How about the test scores? So again, the test score also is like a list in your code, is used to store the accuracy of the KNN model, but this time on the test datasets. We have identified it here, we have the X test and the Y test. For each value in neighbors, similar how the training scores that we have implemented here, it holds the training accuracy for each value. But this time, when you use the test score, it goes through the testing dataset, including the X test and Y test, and holds also the accuracy on each of the test sets. So it's the same thing here. How does the train scores represent? Also, the test scores represent each of the values in neighbors. Test score contains the model accuracy on each of the test data. This tells you how well the model generalizes to new unseen data, which is very critical here. So you need also always to consider the test score has to be very high, because test scores, it represent when your model trains or predicts a new data set that it wasn't trained on and it's unseen. So it uses the trends that it has learned on the training scores, and now, but this time, it learns on unseen data when we have splitted our data set, if you recall. So our test data is equal to 20% of the whole data set. So it's it should be like separated, because we can consider these test scores are being evaluated based on unseen data or new data after being trained on the training data set. Let's try to plot and visualize the results to ensure that it's more readable and understandable and easy to interpret. To, to do that,